Good morning, everyone. We are going to be talking this week about stars. We've left our moon. We said goodbye to Apollo program, and now we're on to stars and stellar equilibrium. One important aspect or idea that we're going to be talking about is a star can go one of two ways here, really. If you're looking at this screen here, these are the slides that are on your Schoology account, but it's talking about the different path a star can take. A star is born, if you will, within a nebula. And we've already talked about that term. Excuse me. So a nebula is a large cloud of dust and gas in space, and inside the nebula, stars will form. Now, a star can go one of two ways, and this particular graph shows you that. A star can become an average size star with average size mass. That is our sun. Our sun is just an average sized star. And someday, as it runs out of its fuel, it will expand into a red giant. It will then expand even further into a planetary nebula where all of the elements that it has formed and produced will be scattered out. And it will someday just kind of fade away, dimming into a white dwarf star. So that is the process that our sun will take. Not really all that exciting if you're looking for a tremendous explosion, if you will, at the end of our star's life. Other stars that have more mass, they will become your red supergiants. They will expand outward, and they will have what is known as a supernova. And after that, what's left over, the dense material left behind, can become a neutron star, or if it's a really big star, a black hole. But remember, the key here is mass. The mass of the star will dictate which path of stellar evolution it takes. One thing that's very important to know is that a star is in a constant battle for supremacy between gravity and internal thermal pressure. What the heck does that mean, Mr. Crowley? Well, being so big, stars have a tremendous amount of gravity, as you can imagine. Well, the star would love nothing more than just to allow the gravity to win out and crush down. But inside, there's nuclear fusion going on, and that produces a tremendous amount of energy and pressure, thermal pressure, meaning the heat and the energy, the radiation that moves up. So we have this equilibrium, if you will, this balance going on. As long as there's fusion going on, the star will not be crushed by its own gravity. But this is a constant tussle between gravity and internal thermal pressure. As long as that balance is there, we call that stellar equilibrium. Inside a star, a very large star, probably a bit bigger than ours, we have different stages of this stellar fusion. We talk about fusion. That is where we have a combination of certain atoms and they produce new atoms. And that is what stars do. And this process is known as nuclear fusion. Well, overwhelmingly, the most common type of fusion is hydrogen fusing into helium. Remember, it takes a lot of energy to compress and to fuse or push together two atoms because by nature, they're not really interested in hanging out too close together. So once the hydrogen fuses to helium, then helium will fuse to carbon, carbon to oxygen, and so on and so forth down the line. Once we see that fusion is occurring and iron is being produced, that is the beginning of the end. And about one day after iron starts to show up, the star will collapse. Because iron is sort of like eating celery. It's really calorie negative. It takes more energy for the star to fuse the iron than the iron actually gives back. All right, that wraps this up. And I'm going to let you go ahead and start on today's activities. Have a great day. I'll be here if you need me. Take care.